So our next speaker is also a short oral presentation selected. His name is Ralph Palmisano, and he's the head of the Optical Imaging Center in Erlangen, at the University of Erlangen-Nuremberg in Germany. And he's going to talk to us about how to entangle SRRF and TIRF to get super resolution imaging using Fiji plugin. So Ralph, the stage is yours.
Right. Good morning, Turku. So we've heard some nice and easy super resolution and also engineering of fluorescence emission and last talk. So my talk is a bit more on a technical aspect. In my institute, we deal with a lot of customers, approximately 250 a year from 50 groups, and they also want to apply TIRF and SRRF super resolution, and that harbors a little bit of a problem. It starts with the force of TIRF, which you are all very familiar with. Instead of having a propagating wave for your sample, you have this evanescent field, giving you a really good signal-to-noise ratio, and hence almost something like super resolution. And if you want to combine it with the power of TIRF, of SRRF, which was described nicely by Ricardo in 2016 here, how you create a gradient field, and then you get this radiality. And the end of it is you have a nice super resolution image post-processed. So combining both of these worlds in one setup like SRRF and TIRF for a free channel experiment harbors some problems in the practical world. What we do have is this Leica Infinity TIRF system, and that is operated, that's the important fact, that's operated on a computer with LASX control software, and we've added this nice Andor camera, and that has worked on a different computer with Micromanager. And that means LASX and MM run independently from one another, and there's no synchronization in between. And this is where the problem kicks in. Benjamin, one of my senior scientists, made a nice movie for our users, which I'm not going to show you entirely. I'm just going to highlight what the workload is that you face if you do a free channel experiment. So you start with adjust your acquisition settings on your microscope, laser power, TIRF angled, intensity, etc. Then you have to do the same for your camera settings, exposure, time gain, camera gain, SRRF parameters. And then you set up the actual experiment. So your bright field settings on the microscope, your bright field settings here. Same applies to your first fluorescent channel here, and the same needs to be applied on the camera, and so on, and so on. And then you're done, hopefully. Done without any errors, like mixing up the order of clicking. Forget a step, like selecting the correct channel. Forget to disable preview in LASX, which means you will have a permanent light exposure. Or you mix up the images before they get merged. So you can see this is tedious, inconvenient, and error-prone. Benjamin came up with, let's make a nice, simple graphic user interface here, where a user only just needs to apply which channels to use if you want to do SRRF or no SRRF, and that should be it in the best of both worlds. So and this is what it looks like. You have, I'm not going through in detail through all of this. So you have this Micromanager script, which will fully automate the entire workflow. So in red here, you see what happens on the computer that runs LASX, and in between, what needs to be done on the computer that runs the Andor camera. So there's a lot of steps you need to perform. And this small script will then listen on a network port for incoming click commands, and it's automatically started at boot time, so all our users don't have to fiddle around with that script too. It just starts and works. And from within the Micromanager, you will send click commands, and if you have a fixed window size, you can define these points here on the screen coordinates, and then everything is nicely harmonized. So we found a solution to increase the convenience of usage, reducing the risk of missing a step, Microscopy control window must have a fixed size. I mentioned that, and must be in front. And currently, I have to admit, we are not able to acquire stacks. And I will show you a few examples from groups working at my institute and utilizing this technology. So the group of Anja Lux and her student, Gina Nusser, they were interested in the display of lipid rafts, so neutrophiles, the monocytes, NK cells, B cells. And what you see here is the normal wide field image. So in green, it's an anti-human antibody against Fc gamma receptor, and in red you see a chlorotoxin B conjugate cross-linked to GM1. And as you would imagine, the resolution is not really sufficient to say, is this a true colocalization or not? So, applying TIRF and SRRF instantly changes the game here. So they got all these, and I'm very grateful, it's unpublished data yet, they got all these information they wanted to see. So is there colocalization, just like here in monocytes, or ain't there any one? Another group, the group of Professor Bogdan from the Clinical Institute of Microbiology, and his senior scientist, Dr. Gerlach, is interested in the interaction of type 1 secretion system components. So these are the components of the type 1 secretion system here. And there's different subcomponents like SRRF, D, or F. And what they wanted to know is the composition of these transmembrane proteins. So what you see here is a confocal image, and that does not really reveal anything. It gives you an idea. It might be co-localized, but you can't say. So applying TIRF, looking here, didn't change that point of view very much. But once we applied SRRF and TIRF, and going down to a resolution of about 80 nanometers, you could see that on the salmonella here, there is definitely a composition of different types of these subunits here. So as I'm not one of these scientists, I'm more running all this place. I'm not going to go into detail here. But we also would like to have a brighter future. A brighter future means TIRF is amazing, but it's only a small field of view, and you have a few problems still working with it. So small field of view here, inhomogeneity, and varying penetration depth of your sample. And there is a solution now out. It is a Q-chip from Interference, which will allow you. Could you play that movie, please, for me? Yeah. Thank you. So this chip here will allow you for a really large field of view on your TIRF sample, and has an almost perfect homogeneity, and it has a well-defined penetration depth on all channels you're going to use. So this all substantial advantages. It is just in the making. We are quite happy to have a first opportunity to work with them and to examine really the potential of that system here. And if you're interested, I think they're here on booth 16 and also have a workshop. But I'd like to point out now to one of my senior scientists, so Benjamin. Benjamin is a guy behind the informatics who does all the coding, whatever, and we are really grateful to have this guy around. And Philip, he is the scientist who helps all these groups here really applying and working on the system itself and applying data. So I mentioned, and I'm grateful for the samples from Christian Bogdan and Anja Lux. And with this, I'm happy to take any questions. Thank you very much.
Thank you, Ralph. Any questions? We have one here. The microphone is coming to you. Just give it a second.
So my question would be that why did you need to do this? Because the SRRF, I mean, you could do afterwards. So this whole complex kind of issue with the two software and so on, I mean, if you would use just the Leica software, acquire the images and do the SRRF processing afterwards. So what's the advantage doing it on the fly? Because Yeah, or was it, I don't know whether the Andor camera is implemented in the Leica software.
So thank you for that. That's a very good question. Thank you, yes. The reason for it, first of all, I know you could do post-image processing doing SRRF on Fiji, ImageJ, whatsoever. And that is applied by groups who run their own instruments. That is not really feasible if you have a central institute running with dozens of users who, first of all, the PIs just say they come up, why is he spending 2 hours on a computer in your institute? What's he doing there, right? So, and this Andor camera is quite nice to work with too. So that's why we were in need of a solution to help scientists to have an improved experience and a time-wise experience on that. That's the reason for it. You could incorporate the camera itself into the Leica software, and I'm sure you could also do with Zeiss, Olympus, Nikon, but it still would not harmonize both, so the settings of both systems. So we've talked to them, and that would just not be feasible. You still would need a different graphic user interface for the camera to use. So the short answer is, in a single user environment, go for Fiji, ImageJ, and SRRF. If you have a multi-user environment, this seems to be the better solution. That was our main driving purpose for it.
Any other questions? If not, let's thank Ralph once again.
Thank you very much.
Okay, and